Let us look at the Neoproterozoic paleogeography. We will take two times 825 million year back and 720 million year back. So, in this presentation this is the first time I am showing the paleogeography. I have not shown the Archean paleogeography, I have only shown in terms of some cartoons how the tectonic style has changed over time. Now, here 825 million year, where does it fall? It falls within the Neoproterozoic era. This is 1000 million year and 825 will be somewhere, this is 720. So, maybe 825 falls somewhere here. This is the time when the different plates have been, the different so called plates have been shown. These numbers 1, 2, 3, 4 etc. are the ways to track the different continents. WA means West Africa, I means India. Now, from 825 million year, if we look into 720 million year, which is younger than 825 million year, where it will be? It will be this one, the boundary between the Tonian and the Cryogenian periods. What has happened? Continents have moved. We can see I was over here, but now it has come at this spot. We can see West Africa has moved and the other continents also have moved. NA and SA are Northern Australia and Southern Australia. 600 million year back, that means essentially we are talking the Ediacaran, because you see this is 635. In the Ediacaran period, this is how the plates looked like. They seem to have joined in this central position. Now, we are going to see the Cambrian. Where does Cambrian lie? In this part of the time scale, Proterozoic ends over here. So, the first division of the Paleozoic, the lowermost division is the Cambrian. That one we are going to see now. And you see this is younger than 600 million year and the age is older than 400 million year, which is over here. So, I have zoomed the Cambrian portion of the geological time scale and you can see the finer divisions, age 2, age 3, age 4 is given, but there is no age 1 in the list and there is an age 10 over there. And by the way, these smallest divisions, there are 10 divisions, and note that the time divisions are unequal, as happens, as is very common in the geological time scale. For example, the duration of Fortunian and that of the age 10 are significantly different. In fact, the Fortunian is the longest time range of the Cambrian. Cambrian is characterized by explosion of life. First explosion of life has happened in the Cambrian. Many early Cambrian groups developed skeletons. This is the time when animals with skeletons came into existence. Before Cambrian, there is no such report of significant development of skeletons. The division of the Cambrian, what is known as the stratigraphic zonation, is performed using trilobites, which is an arthropod and that has gone extinct, and then small shelly fossils. This term small shelly fossils we come across when we read the Vindhyan stratigraphy in Indian terrain. Such small shelly fossils have been reported and then debated as well. Mass extinction happened in the Cambrian. The base of Cambrian is defined by burrow of complex forms. There are organisms that on the soft sediments keep on burrowing. Those trace fossils have been found in the base of the Cambrian. And what were the kind of organisms present in Cambrian? They were free living animals and they were the deposit feeders. They were extracting organic matter, which is carbon, from the ingested sediments. This is the Cambrian paleogeography. Africa was over here, Gondwana is recognized, Arabia is over here. Now, from Cambrian, this is covered in the previous slide, we are moving into Ordovician. Summarily, Ordovician saw a great evolutionary radiation in the seas. The mammals, they were nowhere into the picture. And among the early Paleozoic animals, here you see change of the word, Paleozoic word is used, whereas here I use the word Ordovician. Let us see the difference. Paleozoic has been divided into Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. So, Paleozoic and the not only that, but the early Paleozoic. So, we can see in this succession, at least this portion can be called as early Paleozoic. So, in this time the animals were floaters, either they were floating in the water and in whatever is the direction of the flow they will move, and there were also swimmers, which means they can swim along the current flow and also opposite. These animals cause stromatolites to decline. Previously stromatolites were there, but then they were reduced in number because of their presence. So, while few organisms were flourishing, few other organisms were in decline, and this pattern is seen almost throughout the geological time scale. What is good for one group of organism, the environment, that can also be bad for the others. Late Ordovician glaciation happened in the Gondwana land. We have referred to Gondwana over there. Glaciation took place there. Most of the marine taxa re-diversified in end Ordovician. This diversification means speciation, new species were produced from the marine taxa as well. Now comes, after the Cambrian and Ordovician, the Silurian, and in the Silurian graptolite biostratigraphy has been used, and we will see graptolite biostratigraphy also continues in the Devonian in the next slide. There are fragmentary evidence of simple terrestrial animals, and they are known from the later Silurian rocks. That means, from the top part of the Silurian succession, from here there were fragmentary or evidences of simple terrestrial animals. What happened in the Silurian paleogeography? We recognize a Paleotethys ocean, and this term will be there for subsequent geological periods. South China and North China worked out, Antarctica was here, Australia was there, Arabia was there, Gondwana has been recognized, and it looks very strange from this position how the present day geographic configuration of the continents will happen, but we will see the slides slowly. Here note that when we are studying the geological time scale, one can get into the extreme detail of individual species or fossils or individual genus and how they have evolved, how the plants have evolved, how the animals have evolved. Take any specific animal, for example shark, when they started, how they started, why they started, what is the time of their decline, what is the time of their peak, etc. can go on. Here in this presentation we are doing the subject, we are treating the subject in a very general way for the beginners. Therefore, we cannot get into all the details. The Devonian, which is younger than Silurian, we started journey from Hadean, we crossed Cambrian, Ordovician, Silurian, and now we have come to the Devonian. Graptolite biostratigraphy has been used. Earlier I have used the term over there. In Silurian and in Devonian, graptolite biostratigraphy has been used. Devonian is called the age of fish. The fish in the water were numerous, and is the greatest success of the fish with lungs, what we call as the lung fishes, these kinds of fishes. Glaciation in the southern Gondwana land late in the Devonian. So, here we had glaciation that took place. So, we see there have been several pulses of glaciation on the earth history. there is also time of deglaciation, there has also been time of warming. Whenever there has been a global warming in the past, the ice melted and the sea level increased, moved landwards, and whenever there is a glaciation, ice had formed and the sea level has receded. In both these cases, the ecology got modified and gave a chance for speciation. Whenever we are talking about glaciation, tillites, teals, tilloids become very important. Now, after finishing Devonian, we have come further up in the geological time scale and we have touched the Carboniferous. This is the time of most conspicuous growth of the plants, marshy environment and coalification, coal has formed. This is the geological time when maximum coalification happened on the earth, but this is not the only time when coal formed in the past. For a marshy environment, we need warm, moist climate, and this was widespread in the early Carboniferous. So, early Carboniferous means the bottom part, this part of the succession, this is the overall climate, warm and moist. And in Carboniferous, continents collided and great ice age happened in the mid Carboniferous. Mid Carboniferous means, I can put the line over here, this is mid Carboniferous when again a great ice age began. Now, we see the paleogeographic reconstruction. Paleotethys ocean persists, Panthalasic ocean is over here, the Gondwana is located over here, South America is marked, Pangaea has also developed, here is Arabia and here is Australia. Now, from Carboniferous we come to Permian. What happened? The dry habitats expanded, that means glacial period has ended and dry habitats started expanding. End of Permian, same as the end of Paleozoic. See, this end of Permian is the end of Paleozoic. End of Permian means the top in the succession, this place we are talking is marked by mass extinction, and this is the most destructive one in the geological record. I have already referred the grade 5 when the mass extinction has happened. The end Permian is the most massive mass extinction created by the nature. However, the human beings are creative, in fact the worst mass extinction at present. We will see that in due course. In the paleogeographic reconstruction, we are finding the Panthalasic ocean, the Gondwana, South America is marked over here, and this is Africa, and we know that South America and Africa at present are separated. So, we will be expecting a rift in the geological time like this, they are going to be separated. Now, we come into the Mesozoic. In this succession, we do not see Permian, which is below it ideally and is not shown, and we are starting with the Triassic period, which is the lowest period in the Mesozoic or the oldest period in the Mesozoic. Within Mesozoic, we are starting Triassic. Although the conodonts and ammonoids suffered heavy losses in the early Triassic mass extinction, both taxa radiated markedly during brief interval between them. I am putting inside a third bracket, and this is just for information. In NPTEL exam, I will not be asking questions on this. The gymnosperms dominated in the Mesozoic flora. I will be not asking you, not to burden you too much with information, but this is important to know. Mesozoic is called as the age of the dinosaurs. They started approximately in Triassic and they ended in end Cretaceous, and they were maximum in number in the Jurassic. Frogs and turtles succeeded in Triassic. You have to remember, when we look at the Deccan Trap stratigraphy in India, in between the lava flows where there are the paleosols, we find the fossils of frogs and turtles. A mass extinction ended the Triassic period. There has been several glaciation, deglaciation, interglacial periods. There has also been several mass extinction. The Triassic end, this is marked by a mass extinction. It does not mean all the species got extinct. Few of the vulnerable ones got extinct. Most significant tectonic fact in the Mesozoic is that fragmentation or rifting started in the Pangaea. During the Jurassic period, fragmentation spread westward. We are still talking about Triassic. Younger than Triassic is the Jurassic, but in Triassic the fragmentation of the plates, the Pangaea started, and it will it migrated towards west, and you can see South America and Africa, and in this way a breakage is about to happen. So, now from Triassic, which is covered, we are moving into the Jurassic period. In the Jurassic period, several large igneous provinces developed. LIP in short it is called, and in India one LIP is called the Deccan Trap. Trap does not mean hydrocarbon trap, the beginners have to be alert. Trap comes from the Swedish word trappa, which means steps. The Deccan rocks in India, if you look at the topography, many of the cases they are step like geometry. And Deccan, this word comes from Dakshin, which means it is the southern province also, although it is exposed in the central India to some extent. Jurassic is the peak of the dinosaurs, and you see that as if we can clearly see the rifting has been more prominent, and the South America's eastern boundary or the Africa's western boundary is developing. So, with this the Jurassic has been covered. I am briefly touching the tectonic events and also the organisms evolution, staying brief in all the cases. Now, we come into the Cretaceous. Here above the Jurassic lies the Cretaceous period. Most of the chalk deposition in the type locations in Europe are basically the calcareous nanofossils. I am putting a third bracket, means I may not ask this information. Just remember, Cretaceous comes from the word chalk. Diatoms did not radiate significantly till the mid Cretaceous. I am putting inside the bracket, which means I will not ask you question about this. We have to still minimize the information to the very important information for the general geologist who were taking this course. Some of them will be appearing in the exam. Appearance of new groups of single celled organisms, unicellular organisms, gave marine plankton a modern character, will not be asked, just for your record. Benthic life was modernized, will not be asked. Flowering plants expanded on the land. Evolution of plant is a very big subject. End of Cretaceous, this is important, you have to remember, is the time of the end of the dinosaurs. What can be the reason? One of the hypotheses is that there were a lot of meteorites falling on the earth, and the meteorites came in contact with water and soil, and it altered the ecology and the food chain, and therefore, the dinosaurs got extinct. In more detail, these meteorites brought too much of iridium in the sediments. Iridium rich layer has been found in few places in the earth, and interesting fact is that iridium in concentrated form is otherwise rare on the earth. So, possibly because of meteorite shower that the iridium concentration got increased, and then it is poisonous. The grass eating dinosaurs were first affected, the flesh eating dinosaurs also got affected, and sequentially the dinosaurs got extinct. The narrow oceans expanded. Now, you can see they have got separated and the narrow oceans got expanded. This is the meaning. The sea level rose and climates warmed, the climate warmed. I told you, if there is a warmer situation, then the ice will melt and then the sea level will rise. This also happened in the Cretaceous time. So, in the Paleozoic world, there was elementary forms of life. In the Mesozoic is the middle form of life, and then at the end of the Triassic, we are entering the Cenozoic or the modern form of life. Now, the Cenozoic is divided into Paleogene and the Neogene periods. Let us see the Paleogene in some detail. Paleogene is a time of the cooling of Earth's polar region and the Antarctic ice sheets formed. Only 3 species of planktonic forams survived end Cretaceous extinction, but forams rapidly radiated in the first 10 to the power 5 years of Paleocene. So, this I am putting inside bracket, students need not remember. Flowering plants rose to dominance, they already were getting numerous. Mammals radiated drastically in Paleocene and Eocene, this is important. You have to remember that the mammals radiated drastically in Paleocene and Eocene. Where is Paleocene and Eocene? In Paleogene, the lowest epoch is the Paleocene and then is the Eocene. This is the time when mammals started radiating. Early Paleogene birds were large in size, very large birds were there. Eocene began with a pulse of warming. We said that in Paleogene there is a cooling of Earth's polar region. However, in the Eocene there is a pulse of warming. So, within the Cenozoic and within that is a Paleogene when there was a cooling of the Earth's polar region and the Antarctic ice sheet developed. Eocene is the pulse of warming that has happened. Raise a question, why glaciation happened, why warming has happened? Is it that when the Earth is rotating around the Sun, is it a very ideal movement, or sometimes Earth comes a bit closer to the Sun so that there is a global warming, and when it shifts from away from the Sun is the time of global cooling. So, Paleogene initially we said that the Antarctic ice sheets developed, but then this time also global cooling and drying happens. That we have finished Paleogene, we have come into the Neogene period. The paleogeography resembles that of the present day world. So, in the Paleogene world, we look at the paleogeography, and South America and Africa, they look almost like what we see at present. More changes are going to happen over here. Around 55 million years back, the Indian plate collided with the Eurasian plate. Where is this 55? This is 56. So, 55 will be over here. This is the time when the Indian plate and the Eurasian plate collided and the Himalaya started forming. This time gets revised, sometimes much different ages are provided, but then those are contradicted. In some paper you may find 52 million year, in some paper you may find 56 million year, and it looks like the number revolves around 55 million year in the Paleogene world. And precisely speaking, after the Paleocene ended and when the Eocene has started, or at the Paleocene Eocene boundary also we can think that it has started, the mountain has started developing. Now come to the Neogene world. Paleogene is covered, now here is the Neogene. Neogene consists of Miocene, Pliocene, Pleistocene and Holocene epochs. The paleogeography resembles that of the present world. Now look at the paleogeography. South America, here is India, this is the plateau of Tibet, the Indian Ocean, Australia. It looks very familiar if this figure is shown to a geography student in school. That is why we say that the paleogeography resembles the present day world in the Neogene time. The Antarctic ice sheet stabilized, it got stabilized, and after that is the time in the Greenland area that ice sheet started growing and thickening. Right now in the two poles we have got ice, but this developed earlier and this one developed later. High rising mountains such as the Himalaya altered atmospheric circulation. Himalaya attained such a height that the cloud which was otherwise going from India to far north were stopped and led to the present day monsoon system. So, the foreland part of the Himalaya received tremendous rainfall, whereas the hinterland portion of the Himalaya started drying up. So, what was earlier far northeast of the Himalaya a place of heavy rainfall reduced the annual rainfall. So, in this way high rise mountains such as the Himalaya altered the atmospheric circulation and climate. In the ocean, whales radiated and forams recovered, need not remember, so I put in the bracket. Seasonally dry climate has developed, need not remember, put inside bracket. Explosion of grasses and herbs, this is the time when grasslands developed. It was there earlier also, but wide areas with grass developed. Extinction of large herbivores also took place. Diversification of mammals and the radiation of the primates, and early apes got radiated from Africa and from Asia, in the Miocene time, so that the Miocene is called the age of apes. Students have to remember, Miocene is the age of apes. Pliocene is important, last glacial maximum, what is abbreviated as LGM. During this glacial interval called the glacial minima, the Greenland ice sheets has only been the continental glacier to survive the northern hemisphere. So, when there is interglacial periods or the glacial intervals, only in the Greenland the ice sheets persisted, and elsewhere many of the glaciers vanished. The Fennoscandian shield was once covered with ice. Once the ice has melted and water has moved away, this land is slowly moving up, what is called as the isostatic rebound. As ice sheets expanded and sea level fell down, as I told you, when the ice sheet will expand, then the sea level will fall down. Species migrated to new regions. Migration of the species of animals was common in the Neogene world. For example, a sector of the Himalaya called the Shivalik, which is found in Pakistan, India, Nepal, Bhutan. The kinds of vertebrate fossils we find today, we do not see the corresponding animals. For example, we do not see any giraffe, we do not see any camel in the Shivalik region. Those animals migrated when the environmental change took place, when glaciation happened. These animals moved away, and those which could not move away died and converted into fossils.